Hello, this is Junior Design Team 16's Lab 6 presentation by me, Joseph Kroll, and T. Dorian Pallets, Kevin Hagler, and Christian Martins. For our presentation, we're going to go over the things that we've done for this semester, starting with our sensor board design and ordering, followed by our sensor board manufacturing and testing. Next is our microcontroller programming H-bridge inverter for DC to AC and out to conversion. Then finally, we'll get to our control loop based on the sensor board design.
The sensor board design and ordering. They provide a schematic as the voltage and the current sensor, the top being the voltage sensor schematic, while the bottom is the current sensor schematic. This is the final PCB we decided to go with. This was designed and assembled by Group 16. This was also approved by the TA for production as well as testing. The circuit schematic was created in Multisim 14.2. This was to obtain the values for the voltage and the current sensor. Once again, the current sensor is on the bottom, while the voltage sensor is shown on the top. The simulated outputs are shown below, the voltage sensor being on the left. The target voltage was -3 volts to +3 volts, while the actual voltage was -3.5 volts to +3.5 volts. While the output for the current sensors on the right, the target was 0 volts to +3 volts, while the actual voltage were at 0 volts to +3.25 volts. The components that were purchased is the PCB. Design was sent and printed by JLC PCB. The ICs and op amps, as well as the power terminals, were that was specified by the TA was ordered from DigiKey, while the resistors and capacitors were ordered in bulk on Amazon.
I'll be talking about the manufacturing and testing of our PCB board now. This is a picture of our fully soldered PCB board. We started by first soldering on the IC and op amp chips, and then moving on to the power terminals before individually soldering each resistor and capacitor to test the voltage and current sensors. And here you have the output of our current and voltage sensor tests.
Hello, my name is Christian Martins, and I'm going to be talking to you about the microcontroller programming of the H-bridge inverter for DC to AC conversion. Below is a picture of our Simulink model for our closed-loop control system. We use this this model, to program our microcontroller so that we could properly test our PCB board to make sure that it was behaving and it was assembled correctly. I'm also going to be talking to you about our control loop based on the sensor board. Below on the left, there is a picture of our PCB board connected to our microcontroller, which is connected to the test bench, which was used for testing and for powering this entire lab. On the right, we have a picture of the output waveform, which verifies that our closed loop setup was working. We also got the transient response for the system. We got this by lowering the magnitude of the input waveform and then using the trigger system on the Infinivision oscilloscope to stop the system from taking measurements. Then we increased the amplitude instantaneously via Simulink, which caused the system to trigger, getting a waveform of the transient response. That's the end of our presentation. Thank you very much.